Geologist Joseph Ndolanye. I'm the assistant lecturer from the Open University of Tanzania in the department, in the Faculty of Business Management. And we are now covering Knowledge Area 2 by having lecture 6, which is all about differential and integral calculus. For this topic, we were supposed to be able, and after this topic, we will be able to perform differential and integral calculus kind of equations, and we have to explain the method used to determine the rate of change of any type of functions, and you have to mention and explain the rules that are being used in differentiation. Again, you have to identify and use the basic rules of integration to solve some mathematical equations. And now we have to start with the first part of this lecture, which is all about differentiation or differential calculus. We say the differential calculus, this is the branch of mathematics that investigates the differential, derivative, together with their relations. We say differentiation is one of the two central concepts in the branch of mathematics called as calculus. It has a variety of applications which include the curve sketching. Again, it includes optimizations of functions. Lastly, it's also used to find out the general expressions for gradient and curves of the of endpoint. Now, by having differential calculus, you can be able to cover such kind of a thing. You can sketch some curve, you can optimize some functions. Again, as I said here, you can be able to find out the point of the curve at any given point that the curve has been drawn. And now we are supposed to introduce first with how do we come out with differentiations. When we say dy dx, this is the symbol that it says the small change in the y to the small change in the x. Small change in the y to the small change in the x. Now, this is what we call differentiation. Now, for this differentiation, now we say we are supposed to have the concept and know where that this dy dx come from, where that this dy dx come from. By introducing the introduction of slope, or what we call gradient of certain linear equation, we say is where now you can come out with what we call the small change in the y and the small change in the x. For instance, if you have the vertical line, like the horizontal line like this one, you have the vertical line, what we call the y-axis, and you have the dotted line, that what we call the x-axis. This is an example, and now you can sketch a line by joining only 2 points that is passing through that is by using a ruler. And if you sketch a line, you can have something like this one, and this is the line. You may even call it, for instance, y equals to 2x plus 1. Given this one probably can be the intercept. And now, at these 2 points here, you have point P, for instance, and point Q. Now, when you are asked to find out the gradient or the slope, what you do is to read over these 2 points. This is x1 and this is x2. And now, what you can have from the original point here up to x2, and from the original point up to x1. When you take x2, again, minus with x1, you end up on the small changes in what? Change in x. Again, this is what we call the change in what? in x. If we have to count again from this point here, maybe this is W1, and the other point here where you get Q, this is maybe W2. And now, at these two elements here, when we say W2 is coming from the original to this point here. This, if it is 10, it means it is counted from the original here. Again, if it's W1, assume it is 5. It is coming from here up to here. So the difference of W2 and W1 will make out the change in what? Change in Y. Now, when we are looking for the gradient of this line, we say the gradient is having the symbol small m, and this is the same as the change in Y to the change in what? In x. And now, this becomes the slope of this line. And now, it comes down the other way now. For instance, when you have to sketch the other graph, say this is a curve of such kind. This is the curve of such kind. Now we say, if it could have been a line cutting this curve in such a way, it is cutting in such a way, and now let me draw it here much better, and passing through that way. It means you can have the 2 points here. Say this point is again P and Q. Say this is point P and this is point Q. This is point P and this is point P, where these two graph meet. We have the curve, again we have a linear graph. They are all meeting at point Q and point P. Now, we will say that if you are looking for the gradient of this line, this has become simple. You have to take only the point x of q and the y of q. Again, you have here the x of p, again the y of p. It means now for the gradient of this line, this will become again the changes in y will become the y of p minus this the y of q less the y of p divided by the x of q minus the x of what? Of p. It means you take this y, you minus this y. Again, you take this x, you minus this x. Now, by doing such a thing, we have the gradient of this line. And now, if we now say, now we are looking for the gradient of this curve. The gradient of this curve, it becomes now not possible to have the gradient of the curve, because if we try to get the 2 points along that curve, you will not find any 2 points that can be joined with that curve. And by drawing such a curve, it means if we have this curve that way, the only point you can get will be only 1. So we say that point Q will be coming close to another point P, which was down here, and now you have only 1 point. And this point, we now change the name, this we call it tangential point. This is tangential point, because you cannot have 2 points that can be joined to sketch this curve. Now it means the point Q will come close to P, or we will have the point P being close to what? To Q. And now, by doing such a thing, we do say, if we have to find out the slope for this one, it means you will have now to say, for the changes in y to the changes in x, when we are talking about the curve, this won't be possible, because we had here the y of q minus the y of p divided by x of q minus the x of p. But for this case, you see, the y of q Q is closer and almost coming to be the same as the the Y of Q is almost close and the same as the Y of P. Also, the X of Q is close and almost becoming the same as the X of P. And this is giving us the same as when they become close together, they become, if it is 5, they become 5 minus 5. That will be 0. And again, if we say X of Q is the same as X of P, we have now 5 minus X of P and X of Q, the difference of it will become equal to 0. If we divide, it means this will become 0 divided by 0, something that is giving us something what we call unidentified. This it is not known, and this we say now it is undefined. It becomes undefined. But for our purpose, we need to have the equation that will make us here this equation to be defined. Now to define this one, we have to make sure that the denominator does not become 0. Now if we want to make the denominator not become 0, it means now we are supposed to make sure that this denominator here is going to become 0 by doing what? We have to limit the changes in Y to the changes in X, but we limit the denominator here, the changes in X, to be close to 0, but does not become equal to 0. To become not equal to 0 is what? It is when you have the graph of such kind. If you have the graph like this, it is close to 0, but it does not cut the graph of X equal to 0. Of Y equal to 0. It does not cut here to this graph, and it does not cut here. So close to the X-axis, but it does not cut the X-axis. So we say this is changes in X does not become 0. It just close to 0, like 0.0007 or 0.00008. That does not become equal to 0. Now, when we have such kind of limit, this is what we call the small change in Y to the small change in what? In X. And this is now the constant that have come out with what we call the small change in Y, small change in X, and this is what we call derivative. So this is what we call derivative. And when you are now using such kind of derivative, we say that this is what we call the first principle of derivative. First principle of derivative. So the first principle of derivative will rely on the limit of small change in X being close to 0 for the changes in Y to the changes in X. What we do here is to make sure the denominator doesn't become equal to 0. And that's what we call the limit. Now, all of this, what we are doing here, we say this is what we call the small change in Y to the small change in X. And this is what we call the concept of derivative. And this is what we call derivative, the concept of derivative. Such kind of introduction is what we say the concept of having the word derivative. And now, if we came forward, you can have now some formulas that are generally used in differentiation when you have to calculate some derivative kind of equations. Like when you have to say y is equal to a, this is a constant number. We say in derivative, the first derivative or a second derivative of any constant number. Any constant number, the answer here is what? Is 0. And when you have the general formula for this one, if we have y is equal to a exponent n, for any of the terminal, we say the derivative of this one, dy dx, this will become equals to, you take the exponent here, reduce it by 1, and you put it as the coefficient of this variable. This will become n minus 1. No, sorry, this is, now you have to take first the coefficient as the exponent, you take it as the coefficient, again, the exponent itself have to be reduced by 1. So this is generally, when you have y equals to x exponent n, the exponent is reduced by 1, while the exponent itself is multiplied here as the coefficient. And otherwise, now what you can do is to have another formula. The other formula is when you are supposed to make the product of some factors. This is what we call the product rule of differentiation. The product rule of differentiation will have something like du multiplied with v, and the du multiplied with v, this will become something like this. That is the way on how to multiply some factors. When you have u as one of the factor being multiplied with another factor v, you say now we are looking for the product rule. For the product rule of differentiation, this we call it another factor. Factor, for example, it can be x plus 1. This can become another factor. For instance, it is x exponent 2 plus x plus 3, etc. That's what we call u and v. So it can be the factor which are different also can be the same, but multiplying the two factors. What you do, you take the first derivative of the first factor, you multiply with the second factor. Again, you add with the first derivative of the second factor being multiplied with the first factor. This when multiplied together, you end up with getting the answer for the dy dx. So this will become the dy dx. If you take the two factors, you multiply together by having its first derivative multiplied with the second factor. Again, the second factor is first derivative multiplied with the first factor. Here you have now dy dx of the two factors. The other example is being explained there. And now we can have another formula which is on how to divide now these two factors. The two factors can be divided by having the example there, when you have the u divided by dx of the factors, two factors u divided by v. What you have is now to have the first factor being the differentiation of the first factor multiplied by v. Again, you have to less with the first derivative of the second factor multiplied with the first factor, the whole being divided by the second derivative, second factor out to the exponent 2. This is how. This is like this. When you have two factors like u divided by v, the x, the answer here you have to do, it is to take the numerator, which is u, and make its derivative, du dx. Then this one we have to be multiplied with the second, the denominator factor, which is v. This is less with now the second one, denominator. It will be dv dx being multiplied with u. The whole being divided by the denominator factor to the exponent 2. This is what we call quotient rule. That is quotient rule. And again, you have something we call chain rule. We have chain rule. For the chain rule, this is used to make sure that when you have variables which are different. For instance, you can have y equals to 5t plus 10. Again, you have x equals to, so then you can have, this is t, or else x equals to, say, t exponent 2 plus 1. You see? Now, they ask you to find out dy dx, the first derivative of y. When we say dy dx, why you have y is equal to 5t plus 10. Again, x equal to t exponent 2 plus 1. It means here you have to make it by using the chain rule. How do you make it? Your dy dx will become the same as first derivative dy dt. This multiplied with dt dx. dt dx. dt dx. So you can see dy dx is the same as dy dt multiplied with dt dx. If dt cancel, we divide with dy dx. And now you can see what we have here. It is y equals 5t plus 1. So the dy will be dy. This will be dy dt. It's y with respect to what? T. dy dt will be equals to 5t plus 10. The derivative of this one will become the same as 5. Again, we have x equals to t exponent 2 plus 1. This will now, if you make differentiation here, you end up on getting dx dt is equal to this term here, it becomes 2t. So we have dx dt, again we have dy dt. So we can say we have to make it dy dx equals to dy dt. dy dt is straight there, it will become 5. But now we have dt dx, while here we have x dt. So to have dt dx, it has to be 1 over 2t. This will become dt dx, the inverse of it, because this is 2t over 1. dx dt is 2t over 1. If you want to get dt dx, it means you make the inverse of it. You multiply now with 1 over 2t. So your dy dx will become the same as 5 over 2 multiplied with 1 over t. This is dy dx by the help of chain rule. By the help of chain rule. Now, by that rules of differentiation, we go to the other part, which is how to use now this differential calculus in finding out the maximum and the minimum values of n of the function. We say for the maximum or minimum, when you are looking for that one, what you are doing, in fact, you are looking for the extreme values. While now we say the point where these values are reached are also known as stationary point. And with any function, when you have the point whereby the values of that function with its first derivative being equals to 0. When its first derivative is 0, you will have the extreme value. If dy dx equals to 0 of n of the function, we say now you can find out the extreme value. But if you have again the second derivative of the same being less than 0, here we say you can obtain the maximum value. Again, here you get the maximum value, But if we have the second derivative of the same factor being bigger than 0, here we say we get the minimum value. And when we say maximum value of the function and minimum value of the function, what do we mean? This can be shown like this one here. If we sketch the graph of a curve that is looking like this. For instance, this is y-axis and this is x-axis. Now, by plotting the curve of such kind, at this point here, we have a turning point. This turning point here, we say this is the maximum value of this curve. Again, at this turning point here, we say here we have the minimum point. So this point is minimum, and this point here, it is what? It is maximum. So we have maximum point or minimum point of that curve. So when we want to find out the maximum point, a middle point, we have to take the first derivative to see first the extreme value. When we say the extreme value for the curve, we are meaning some values of x here along the horizontal axis. For instance, you can have here, this is the xy. Again, you can have the point here again, which is for the turning point at minimum. This x here, these two x of the turning point, x1 and x2, these are the extreme value. These are what we said, it is being obtained by having the first derivative of the function itself being equal to 0. After computing it equal to 0, we end up now only having the equation that can be solved and get some x, some values of x. Those values of x are what we call the extreme values. And the other part is on how to make the integration now. The integration part. The integration is the second part of the calculus. And we have two types of integration. These are the integration that contain no boundaries. That contain no boundaries. So when you have the integration, you have to integrate certain equation. We need two kind of integral, whereby we have finite integral and the infinite integral. Finite integral and integral that do end. It has boundaries like a and b. These are what you call finite integral or infinite integral. Finite integral. Whereby infinite integral and integral that does not have any boundaries. And now, when we say integration, it is the opposite or it is the inverse of the differentiation. For example, if you have y equals to x exponent n, we say dy dx is equal to n multiplied with n minus y. This was the derivative. Now, when we say derivative, its opposite or its inverse is integral, we mean that if you make the integration of n x exponent n minus 1 dx, you end up with having x exponent n. So the equation itself to the integral, when you come down having the answer, so this is what we say. As the answer for y, dy dx is n x exponent n exponent 2. If we integrate the answer for the derivative, you end up on getting the equation, the original equation itself. So it is opposite to each other. They become opposite to each other. In general, we say that when you have to make the integration of any of the factor, like to integrate, for example, x exponent n dx. What you do it is to make sure that what you do, you take this exponent, you add it by 1. You add it by 1. Then after the value get there is what we divide here as the denominator. This is how you can have the answer. So it means when you have to integrate x exponent 5, here exponent 5 dx, here the answer it means will become x exponent 5 plus 1 divided by 5 plus 1. So the integral for x exponent 5 dx will become the same as x exponent 6 divided by 6. That is the part of integration. And now, by that part, we say that at least you can have some exercise that you can do for yourself at your own time. And this makes the end of differential and integration calculus. Thank you for listening.